everyone, welcome to Geometry Lesson 2-2, Conditional Statements. Let's start with looking at what a conditional statement is and some of the basic terms involved with conditional statements. So a conditional statement kind of like is an obvious thing that says it's a statement that introduces a condition. For example, if I get an A on my test, then my mother will be happy. Okay, so it's introducing a condition. Now, we can use symbols to write this. It's like P, arrow, Q. So P is this first part. The arrow represents the then, and then Q is the second part. And we can also use a Venn diagram to describe this. The if part of the statement is inside, and the then part of the statement is in the outside. Now, the P part is known as the hypothesis. It's the part of the statement that follows the word if. The Q part is the conclusion. It's the part that follows the word then. Now, technically, we can write conditional statements that don't have the word if and then in them. But for this class, please write the word if and then so I can tell that you understand which part is the hypothesis and which part is the conclusion. And for our class, we're always going to write the hypothesis first and then the conclusion. Always in this order. Don't forget the words if and then for our class. Now, many statements can be rewritten as conditionals, and all we need to do is figure out which part of the statement depends on the other. So let's look at an example to see how that would work. Our first example, we're just going to figure out what is the hypothesis and what is the conclusion of each conditional statement. So in part A, it says, if a butterfly has a curved black line on its hind wing, then it is a viceroy. In part B, it says, a number is an integer if it is a natural number. So see if you can figure out the hypothesis and the conclusion for both of these statements, and then press play to see if you're right. Okay, so what I did is I made the hypothesis this nice blue color and the conclusion this pink color. So in part A, the hypothesis is if a butterfly has a curved black line on its hind wing. Notice that is the statement that's associated with the if. Okay, the conclusion is then it is a viceroy. Now technically, you don't need to have the words if and then included in each of those, but it's actually the statement. So it is a viceroy is our conclusion. In part B, it actually starts with the conclusion. It says a number is an integer if it is a natural number. This is the if statement. It is a natural number is your hypothesis. The then statement, the conclusion, is a number is an integer. Okay, let's take a look at another example. In this one, we're going to actually take sentences like part B that aren't exactly written as conditional statements and actually turn them into the format that we need. In example 2, it asks us to write conditional statements for each of the following things that they've given us. In part A, it says the midpoint M of a segment bisects the segment. And then in part B, it gives us that Venn diagram with birds and blue jays. So do your best to write these as conditional statements and then press play to check your answers. In part A, I can say if M is a midpoint of a segment, then it bisects the segment. Notice they've given us the condition that we have a midpoint named M. And then if we have that midpoint, then a segment will be bisected. Okay? So our result is that the segment is bisected. Our condition is that we have a midpoint for our segment. Okay, in part B, this is the hypothesis, blue jays. So I'm going to just add a few words in there to make it sound like a normal sentence. So I can say, if it is a blue jay, then this is my conclusion. Then it is a bird. So I just added a few words to make it sound more like a sentence and less like, if blue jay, then bird. Okay, I want it to sound like real English and not like I don't know what I'm talking about. Okay, so let's take a look at truth value next. Truth value is something you've been doing for years, but we've never called it truth value before. Basically, it's asking you true or false. Okay, that's what truth value is. Now, with conditional statements, there's this very interesting thing that happens. A conditional is false only when the hypothesis actually is true and the conclusion actually is false. So we check the hypothesis first. If it is false, then we automatically say that the statement is true because we don't know what would happen in a world where that original hypothesis actually happened. So if the hypothesis is false, the statement is true. If the hypothesis is true, you need to check the conclusion to figure out the truth value. Okay, I know that's a bit weird, but we'll take a look at it in class and hopefully I can clear up your questions. Now, to prove that a statement is false, you need to find a counterexample in which the hypothesis is true and the conclusion is false. Okay, so to prove that something is false, you need a counterexample that will make the hypothesis true, but the conclusion will not be true. Let's take a look at an example. Example 3, it says, determine if each conditional is true. If false, provide a counterexample. So in part A, it says, if today is Sunday, then tomorrow is Monday. So you're going to think about what happens if today was actually Sunday. So if it was Sunday, would this be true? Okay, so think about that, decide on truth value. In part B, it says, if an angle is obtuse, then it has a measure of 100 degrees. So think about, if I had an obtuse angle, does this have to be true? Okay, decide on a truth value. If it's false, give a counterexample. In part C, it says, if an odd number is divisible by 2, then 8 is a perfect square. So think about if this is true, and then think about the rest of the statement. So pick a truth value. If it's false, give a counterexample, and then press play to check your answers. Okay, part A is true, because if the hypothesis was true, it can be Sunday. Would the next day be Monday? Yes, it would. So A is true. In part B, this is false, because not all obtuse angles are 100 degrees. I can have a different measurement. So I just need to give a counterexample. So I used 120 degrees. Okay, 120 degrees is obtuse, but it is not 100 degrees. You could pick a different measurement if you want. This is just the one I picked. And that is the counterexample because it's a specific example that makes it false. In part C, if an odd number is divisible by 2, there are no odd numbers that are divisible by 2. This can't possibly happen. And this is what I was talking about. If the hypothesis is false and can't possibly happen, we immediately say that the statement is true, which seems very weird, okay? But that's what we do, because we can't say what would happen in a world where an odd number is divisible by 2. Maybe in that world, 8 would be a perfect square, okay? So we can't say that this is false. It is true. Now let's take a look at another term word that we have. Negation is another term word, and it means that we're going to change the truth value of a statement. Essentially, what we're doing is we're just adding a not into the statement, or we can remove a not. So if I say 2 is not odd, okay, to change the truth value, to negate that statement, I'd pull out the not and say 2 is odd, and it would change the truth value of my statement, okay? Or if I said 2 is even, okay, I could add in the not, and I could say 2 is not even, okay? So I'm just playing with not. I'm either adding it in or pulling it out. Now the symbol for the negation is this little squiggly line. It kind of looks like a tilde that you see in Spanish class that goes over the N. Okay, it's just a little squiggly line and it means not. Okay, so not P. Now let's take a look at one last group of terms. These are related conditional statements, and let's see how they're all related to each other. Okay, so our original conditional is what we've been talking about so far. The hypothesis is here and the conclusion is there. So it's if P, then Q. Now the converse is going to switch the order there. Okay, so it's going to switch these. And the way I remember that is that converse is a type of shoe. And it's like getting new shoes and then doing a fun dance move where you switch your feet. to show that you love your shoes. Okay, so in this one, we would switch the hypothesis and conclusion. So the previous thing that was a conclusion comes first, and then the hypothesis comes. An inverse is where we take our original conditional and we negate both the hypothesis and the conclusion. So we add in nots in the hypothesis and the conclusion, or we remove the nots if they're already there. And finally, a contrapositive is where you do both. You switch the order and add in the nots. So you switch the order and negate. Okay, we'll talk more in class about how this all works, but hopefully you can get this down in your notes. And don't forget to leave room for examples, because we have examples about all these different types of things. Okay, so that's it for this video. I'm sorry about all of the writing, but there's a lot of writing in this lesson.